All right. Well, good afternoon, everyone. I've got 2 o'clock on my dial. Time to kick things off. Welcome to this next edition of the National Corrugated Steel Pipe Association's Real Deal on Steel webinar series. Thank you all for attending this now 6th session of our 7-part series. I'm Mike McGough, Executive Director of the National Corrugated Steel Pipe Association, NCSPA. And as usual, I will be moderating the webinar this afternoon. Only this time I'm going to be flying solo, so no breathers for me today. I get to play all 60 minutes. Woohoo! So today, we're going to be talking about some of the unique qualities of corrugated steel pipe, or CSP, pipe arch, and structural plate buried bridges with regards to the product's traceability, the quality checks that the industry has in place at the steel manufacturer, and also at the product fabrication facilities, and the recently developed certification program adopted by our board of directors that is being implemented through the independent auditing agency, Quality Management Company, LLC. Now, a quick recognition of our sponsors of this webinar series. These webinars are being brought to you by, of course, the National Corrugated Steel Pipe Association, NCSPA, in partnership with our friends at the American Galvanizers Association. As I said, this is the 6th installment of this webinar series. Hard to believe we've come this far and that there's only one scheduled future webinar remaining. Thank you all again for joining us on this journey. Our lone remaining webinar will be on rehabilitation practices. Of course, this will be brought to you in 2 weeks from now, Thursday, August 6th at 2 p.m. Eastern. Also, just a quick reminder that PDHs are available for those participating this afternoon, so please be sure to complete your information and take advantage of this free opportunity. There will also be recap of these previous topics today as they each build from each other. But if you are unable to attend any of the previous sessions and would like to hear it again for further study or would like to review the slides presented, they can also be found on the NCSPA website. Membership of the NCSPA is comprised primarily of steel coil manufacturers, coaters, and fabricators. The mills or manufacturers will produce and coat the steel sheet coil and then ship it to the various fabricating companies that will in turn roll form, rivet, or fabricate the steel into the various profiles for either pipe arches, or structural plate buried bridges that have been installed under our nation's highway system for over a century. Now, beginning at the beginning is what Lewis Carroll said, and the traceability of the steel used to manufacture corrugated steel pipe arches, and structural plate can be traced all the way back to its beginning. Mills that produce the coil, which is used to fabricate these products, provide a certified mill test report containing the compositional information of the steel. Standards, specifications, and test methods developed at both the ASTM and AASHTO levels are the backbone used to prove this out through chemical analysis and mechanical testing. As Ray Wilcock with the Corrugated Steel Pipe Institute discussed during our last webinar, in most cases, CSP, like all other products, starts out with scrap. This scrap from nearby scrap piles is transported to the steel mill via rail or truck to be melted down. Once the scrap is melted, the composition of the steel, the recipe, if you will, is set. The molten material is then cooled into a bar form and rolled out into the coils. CSP and related products are made following strict guidelines and specifications. Once the steel is rolled out flat, it can then be rolled into coil form for easy transport throughout the plant. It is then unrolled again to run through the various coating lines. Primarily for our products, these are galvanized and aluminized. Air knives are used to control the thickness of the coating. It's these finished coils that are then shipped to the fabricators by truck or by rail for the forming into the many corrugated steel drainage products that you see today. Fact: CSP is the only drainage solution that provides the ability to identify a specific piece of steel in a drainage structure and determine its mechanical properties, chemical analysis, and parameters associated with its production. Well, now how do we do that? I know the answer may seem obvious to some, but the reason we're here today is to get to the devil in the details. This answer, of course, is the heat number. Now, what exactly can a heat number tell you? Well, for starters, it will tell you when the steel was produced, both the date and time. It will tell you the recipe of the steel, chemical composition. We will get into more detail on that in a little bit, but we'll also tell you the process times and whether the steel was produced using a BOF, or basic oxygen furnace, or an EAF, an electric arc furnace. This next slide shows a few flat facts about global steel production. 1.8 billion tons are produced annually. The vast majority of this is produced in China. I mean, they lap the field in that regard, but 1.8 billion tons are produced annually. From raw material perspective, iron ore, which is about 5% of the Earth's crust, makes up 50%. Metallurgical coal makes up 28% of the composition, and then recycled is roughly 16% overall. Now, the two methods of production that we talked about before, BOF and ALF, BOF makes up 70% of the production capacity here in the US, and EAF makes up about 30%. In an EAF furnace, recycled material is the main ingredient. I think we all know that steel is the most recycled material on the planet. That being said, 96% is the efficiency rate going from raw material to the finished product, with slag being the main byproduct. Of course, this can be used in cement and other areas. Now, what else will a heat number tell us? It will also provide us with these four nuggets of information. Essentially, the quality parameters that are at the melt facility, the quality parameters associated with the casting of the steel, the process times at the caster, as well as the casting speeds and the temperatures. This next slide shows an example of a standard certified mill test report. Please note that due to Buy America regulations, the requirement is that this material is melted and manufactured here in the good old US of A. This slide shows us the chemical composition of this particular heat. Carbon, manganese, phosphorus, sulfur, and silicone, copper, nickel, chromium are all part of the composition. This will also show us the COIL numbers. See if I can get my pointer going. There we go. So you have your chemical composition. You have your heat number here. This shows that it's manufactured according to ASTM A929 or AASHTO M218. So this is reflective of a galvanized sheet. So you see when the coil is made. Now, these are numbers from a parent coil. So typically a parent coil is much wider than a corrugated steel pipe roll forming mill can fit. So then these parent coils are slit down into what's called a child coil. You can see from this particular example, we have 3 child coils from this particular parent coil. This slide shows us the coating weight test results from that particular coil. It's important to note that this coating weight is the combined weight of both sides. The standard test method is what is called a weigh strip weight test per AASHTO per ASTM A90. We also show the mechanical properties of the steel here, which are the yield, tensile, and elongation. The mills are required to be accredited to conduct this testing. This shows an example accreditation to conduct the mechanical testing. This next slide shows us the accreditation for chemical testing. Why is this all important? During our second session, we covered the structural design methodologies used to develop fill height tables for each standard diameter, gauge, and profile of corrugated steel pipe and pipe arch using both the AISI methodology and the AASHTO load resistance or LRFD calculations. The inherent consistency in steel production is why we are able to have these consistent calculations. From one heat to the next, those mechanical properties, the minimums on the yield, the tensile, and elongation, allow us to develop these consistent tables from the structural perspective. So while there are seemingly countless options out there, again, these standard properties allow for straightforward design calculations. These result in fairly consistent fill height tables regardless of what methodology you use, whether it's AISI or LRFD. You can certainly adjust variables and factors, and this will have some effect on the tables, but in most cases it will be realized in the maximum allowable cover. But these maximums are always exceeding the maximum heights from our competing products. And once again, this is calculated by evaluating the ring compression strength of the pipe, also known as the thrust. Also, by a pipe's ability to withstand the bending failure of the pipe wall. Thrust is calculated by combining two factors, dead load and live load, then multiplying that combined load by the diameter, dividing it by 2, right? Simple and straightforward. I know we've gone through this before. The soil structure interaction between the pipe and the backfill is different for flexible pipe and rigid pipe. For flexible pipe, as the system is compacted and consolidated, the pipe will deflect to a certain degree along with the soil, shedding some of the load. While for rigid pipe, due to the increased vertical arching factor, it will attract load. The ratio of this interaction is illustrated on some previous slides, but for a given loading condition, a rigid pipe will likely have to be designed to carry up to 3 times the load of a corrugated steel pipe. This slide boils the structural design procedure down to 7 easy-to-follow steps. Once the properties of the pipe are determined, i.e. the gauge, profile, and diameter, along with the loads that the pipe will experience and the compressive strength or the thrust acting on the pipe wall, the maximum allowable stress can be checked. The flexibility factor can then be checked, and if applicable, if it's a riveted pipe, the seam strength can also be checked, and if it's a pipe arch, the corner bearing pressure can also be checked. If you remember way back on our first webinar, we discussed the types of coatings available for corrugated steel pipe. These coatings include galvanized or zinc-coated CSP, aluminized type 2, aluminum-coated CSP, polymer laminated, and post-pipe fabrication-applied coatings in paving such as asphalt-coated or concrete-lined. Upon reviewing each of these coatings, we covered the material specifications that have been developed, the decades of research that have been conducted, and the types of protection they each provide, ranging from the cathodic protection provided by galvanized steel and the barrier coating of aluminized type 2 to the environmentally resilient polymer laminate coating, which results from a strong chemical and mechanical bond developed during the laminating process. So these slides show you, again, they're just a recap from our previous webinar. They show you some of the characteristics of the coating weights, how long they've been in use, and the type of coating they provide. Now this schematic shows you a cross-section of what an aluminized type 2 coating looks like. You can see the steel substrate, you have a hardened aluminum alloy layer, and then you have a lighter weight aluminum alloy layer above that. This next slide boils that down into what would be, a range for those particular coatings. Now, I'm not a chemist, but I've been told Archimedes is the principle that applies here, and what that means is you'll notice that there are some ranges on the thicknesses here within the hardened and the free aluminum alloy layer. So as the steel cools, obviously the thicker the steel, the longer it will take to cool. The longer it takes to cool, the thicker this aluminum alloy layer will be, and the thinner this free aluminum alloy layer will be. Now we have a video also on our website that talks a little more in detail about this, but with the advent of gauges to record thickness or check thicknesses on this, there's a good chance that the gauges are calibrated to only read this free aluminum alloy layer. So there's a chance that by doing it this way, you would get a false low reading, essentially. So that takes us back to ASTM A90. The weigh strip weigh method will be the referee method under all circumstances. From the polymer coated perspective, we talked a little bit about the production here. Again, this shows a schematic. We have the steel substrate, the steel aluminum the steel alloy layers. And then, again, as we talked about before, a polymer coated steel pipe is basically it's a galvanized coated pipe with a 10 mil polymer laminate film trademark trench coat over top of that. Now, this is a distinct process in and of itself. Once the galvanized coil is manufactured, it is sent to the laminating facility. This diagram shows you the processes that the coil will go through to become laminated. So there's an entry end where it accumulates. There's a cleaning and pretreatment that occurs. There's a prime coat that occurs, a top coat that occurs. It's quenched, reaccumulated, labeled, and then recoiled. Those are the essential steps. We also talked about coating performance and how we got to what we know about each of these particular coatings and how they perform in the various environments. This information is derived primarily from over a half a century of research on thousands upon thousands of pipe installations. Caltrans drove the study for galvanized to develop the curves based off of that. Aluminized Type 2 studies in partnership with FHWA and some other independent agencies and members of the industry. Sites have been looked at for over 60 years. The most recent one was conducted back in 2014, which means that we're probably going to be doing another one here in very short order. But you can see there are sites all over the country in this particular study. Similar on the polymer front, a long-term field investigation was done back in 2012 with over 60 sites investigated from states ranging from Wisconsin to Louisiana, New York to Michigan to Arkansas. Once again, we anticipate conducting another study on these particular sites again in the near future. Now, what does that all result in? It results in this estimated material service life table for each of the particular coatings. So what you can see here is the estimated service life based off of the site, environmental conditions, and the maximum abrasion levels that an application would experience. Two weeks ago, we talked about sustainability. Sustainability has many meanings, but the definition that is most applicable for our situation is that it focuses on meeting the needs of the present without compromising the ability of future generations to meet their needs. This is based off of 3 pillars with regards to this particular aspect of sustainability. The first one is economic, so this amounts to the profitability. The second is the environmental aspect of it, basically the planet, and this is where we focused our talk a couple weeks ago. Thank you, Ray, again. And the third is the social aspect of it, or the human resource aspect of it. Now, the first step, as we talked about, was determine where we are today. Today's snapshot in time as far as the carbon footprint goes with respect to the products that our industry produces. The second step, naturally, is where do we need to go? What do we need to get to? Ray talked about the Paris Climate Accord and recommendations for 2050 to be carbon neutral. So how can we improve upon where we are today for future generations? You know, make sure they have the chance to enjoy the environment that we enjoy, clean air, clean water, and et cetera. So taking this all into account will result in what's called an environmental product declaration. CSPI, the Corrugated Steel Pipe Institute, has done a tremendous amount of work to develop one of these for corrugated steel pipe and related products. This is available for download from their website, so if you'd like to take a look, please do so. Now, what are the environmental impacts of CSP? So, EPD that CSPI developed looked at a cradle to gate plus an end-of-life recycling option. This was conducted by a third-party review. You know, obviously, being participants and employed in the industry, it's not, we would be considered biased. So, they hired a third-party engineering firm to conduct the science behind this. Again, this is just a snapshot in time as to what the impact has on the environment. The unit that they're using is a 1 metric ton. And then the standards that were used to develop this environmental product declaration are these 4 particular ISO standards. ISO 14025, 14040, 14044, and 21930. Again, we're not going to get into the details on that, but just wanted to make those available for reference. So what are some of our industry's plans going forward? They would fall into 2 primary categories. First being transportation, one, and then the second being manufacturing. So transportation, the advent of electric vehicles will certainly play a large part in that. That will also work into the manufacturing aspect through electric vehicles and forklifts and that sort of thing. There will be retrofitting of plants, the capture, recycling, and elimination of natural gas, oils, lubricants, and propane with alternative technologies. So we, as an industry, are also trying to move into the future. Additional plans going forward. So, steel today makes up approximately 7, 8, 9% of CO2 emissions. So, we're certainly looking to cut this. Gases from the steel making, once cleaned, are used internally to produce steam and electricity. One other plan. One particular major supplier is expending upwards of, and Ray had talked about this, upwards of $200 million per year on research and development to get to zero carbon emissions. Again, 3 technology pillars would be the use of electricity, the use of hydrogen, and storage, utilization, and reduction of carbon itself. Public policy supports this. Public policy support is needed for this as an accelerated transition. Moving right along, let's hop into, I think what a lot of us are here for today, and that's the discussion of quality control, quality assurance, quality verification, and certification of corrugated steel, pipe, and related drainage products. For this particular portion of the webinar, we're going to start at the top by gaining an understanding of what our friends at the Federal Highway Administration, FHWA, and their stance is on quality assurance regulations. So this particular slide shows a screenshot from their question and answer webpage detailing quality assurance regulation 23 CFR 637. The first thing you'll notice, I guess, is the word pavements all over the page. Now, why is that? Well, that's what this regulation is primarily driven for. So one of the first questions that you'll see on that page is, do the regulations cover all materials that are used on federal aid projects? Now, I highlighted and underlined some of the major portions of it. And the basic answer is no, it does not cover all materials. The regulations do not make any distinction in materials in the regulations, but they were meant to cover project-produced materials. Now, these materials would include such things as embankments, hot mix asphalt and aggregates, and Portland cement concrete. These project-produced materials may be produced by commercial operations not physically located on the project, so that's why that's important. It goes on to say that the regulations were not meant to cover manufactured items. Well, what's a manufactured item? Well, these include, but not limited to, such things as reinforcing steel, admixtures, paint, and of course, corrugated steel pipe. So enter in AASHTO R38. The American Association of State Highway and Transportation Officials have developed this standard, and it helps agencies differentiate between what amounts to the 3 different product types. Now, the first one, as we discussed just now, are project-produced materials. Again, hot mix asphalt, PCC aggregates, and the like. Pavements. The second category are fabricated structure materials. Bridge beams would be one example of that. And then a standard manufactured material, again, you guessed it, CSP. So it's defined within this particular standard what a standard manufactured material is. So it's mass produced under highly controlled and largely automated conditions. The properties of the product are stable with no potential for alteration under proper transportation from the manufacturer to the project site, and they arrive in a solid finished state and require only installation. Again, corrugated steel pipe, standard manufactured material. So this is a picture of what tops out as a 144-inch diameter pipe, 12 feet in diameter. Another interesting part of this is look at the length. This is not a standard 20-foot length. This is much longer than that. So, again, we discussed this in previous webinars. The flexibility in design, fabrication of CSP and related products is almost boundless. R38 further defines this in its table 1. You can see project produced materials. Talked about all of that. Fabricated structural materials, precast boxes, pre-stressed bridge beams, and then standard manufactured materials. Drainage systems, i.e. corrugated metal pipe. Moving along, we as the NCSPA have developed a program around R38, R18, and ISO 9001 quality system management and quality assurance standards. We have full industry participation in this particular program that not only includes the fabricators of the pipe, but also includes our mill suppliers. To date, we've had 55 facilities finish a stage 1 review, and we'll get into what that entails a little more in a bit, with 18 facilities finalizing their applications and finishing up their paperwork. Now again, Quality Management Company LLC is the independent auditing agency used for this program. What are their credentials? Well, they have been the auditing firm for the American Iron and Steel Institute, the American Institute of Steel Construction certification program for well over 20 years. So they are independent. They bring a high level of experience, consistency, integrity, objectivity, and responsiveness to the program. I'd like to point out that pipe arching is part of this, as well as plate will be something to be adopted in the future. Like most other programs, we have easy access to this through the NCSPA website. Login access is available to both member companies that are participating, as well as agencies that would like to see the progress on certain facilities. So what is the scope of this of our certification program? Here is the standard itself. It's broken out into 3 chapters. Chapter 1 is the general requirements, which would encompass the quality system manual and the like. Chapters 2 and 3 are specific to the types of production facilities, i.e. the corrugated steel pipe fabricators themselves, and then the manufacturers who produce that coil. There are 2 primary activities involved in this program. The first is a review of the company's quality system and all their documentation. The requirements are set forth in this certification standard. Again, this document was developed based on the basis of the R38, actual R38 and ISO 9001. The second activity is, I'm sure you've all guessed it by now, would be an on-site audit of the facility. So this is required once a year. Of course, under current state, that is increasingly difficult. Virtual audits are an option. We have yet to do that for our facilities as of yet, but that is something that will be coming in the future. So let's take a quick look at the Chapter 1 general requirements and what are contained within. Obviously this covers the quality system manual itself and the quality management system. It covers management's responsibility. So that would be their policy for quality, information and requirements on a periodic management review. Of course, organizational structure, internal communications. It also encompasses the control of the management system and project documents. So again, that will contain the quality management system document review and approval, the revision control of those documents, access to those documents, and the communication of any revisions. Similarly, on the project side, revision control and access. It also includes requirements and procedures for the maintenance of quality records, the retention of those records, the storage of those records, and the retrieval of those records. Purchasing information is required within the quality system. Purchasing data, the selection of subcontractors and suppliers are all part of this. Material identification is part of this, whether that's with regards to the coating, bolt, nut, and fastener, how they are identified. Again, material traceability corresponding to the certified mill test reports are all part of it. Process controls are part of this. That includes equipment maintenance primarily and the documented procedures around maintaining your equipment, minimum inspection, preventative maintenance, and the like. Of course, inspection and testing is also part of this. The assignment of QC and inspection and monitoring, receiving in-process inspection, final inspection, and inspection records, all encompassed within the general requirements portion of this chapter. Equipment, calibration, inspection, and measurement of test equipment, right? So each equipment must be uniquely identified. A list must be maintained. What are the frequencies of the calibration? What are the methods? What are the procedures? All need to be documented. Control of nonconformances, obviously very important, right? So nonconformance is both within the management system itself or the product and the workmanship of the particular products must be documented. The corrective action taken to make sure that these nonconformances do not occur again must be documented. Procedures must be laid out. Marking, labeling, handling, storage, and delivery, all contained here, right? Documented procedures. Training and competency, mill operators, and the like, all have to be included. Typically, it's once a year, right? So training would be initial part, and competency would be once a year or on some consistent interval. And of course, finally, an internal audit would also need to be documented as well. So that covers the general requirements written within the NCSPA certification standard. The second chapter covers the supplemental requirements that are required for the pipe fabricators themselves, right? So these are the process controls that must be maintained to ensure that you are producing the quality pipe that we all expect. So this would include pipe dimensions. That includes verification of the steel thickness and the coating thickness and the coating type. That would include measuring and checking the depth of the corrugations, checking seam strength, whether that's through a pull test on the helical seams or riveted as well. The end finish of the product, right? Pipe arching dimension requirements are contained within this particular aspect of it. And then you get in some of the nuanced parts of it. Perforations, right? Not all pipe is perforated, clearly. Perforations, as we talked about in our retention and detention webinar, are for retention systems. Workmanship practices, repair practices, labeling, storing, and then instructions for loading, handling, and shipping. All contained within this chapter. Now, these requirements are all derived from the AASHTO and ASTM specifications. So ASTM A760 and AASHTO M36. They're all called out, and that is exactly where these are extracted from. So this document is based on existing standards. So just kind of walking through the process in a little more detail. Here we have a photograph of a pipe mill. Here's the coil. It'll run through some stands to where a lock seam is formed, wound out through the bay to the given length, and then it's cut. This particular part of the mill is on rollers, and this is what sets the angle, the helical angle, which determines the diameter of the pipe. The shallower the angle, the bigger the diameter. The steeper the angle, the smaller the diameter, is what that amounts to. This next slide shows you some pictures down the stands. So you can see the rollers, the stands of rollers that are here that form the corrugations. At the end, this is where the lock seam is formed, where the steel is folded over itself to create that tight seam to make sure that the pipe maintains its strength through fabrication, through handling, and through installation. This next slide just shows a couple of more pictures of the lock seam being formed. And then one more of another mill, a different type of mill, and some polymer coated pipe being made with a few sticks shown here as they're sent down the slide. And then the final chapter, chapter 3, covers the supplemental requirements for manufacturers or the mills themselves. So again, the process controls contained within that are two primaries of the chemical composition, right? So this is the elemental composition, carbon, manganese, phosphorus, copper, and the like, the minimum and maximums of what those elements can be, and then the sampling and testing procedures that must be conducted to ensure they are within range. Also, the mechanical properties, yield, tensile, elongation, what the minimums are there, minimum requirements are there. Of course, coating requirements, right? We talked about this. Service life is primarily derived from the coating. If the coating does not meet specification, you're not going to get the service life that you are anticipating. So coating requirements, i.e. the total amount of coating weight, right? Again, that's both sides of the coil and what the minimum and maximums are. Again, weigh, strip, weigh is the referee method there. A triple spot test is what's used. A sample is taken from the edges of the coil, not all the way to the edge, within, I think it's have to be 2 inches from the edge, as well as the center of the coil. So a triple spot test is what is used for this weigh, strip, weigh. Of course, the dimensions and tolerances, right, of the thickness and the widths, and then the marking, the stencil that you see on the pipe, right? So it's an ASTM A929, M218, 16 gauge coil, heat number, etc. So that, again, is all included in the certified mill test report that our manufacturers send along with the shipment to our fabricators. Traceability. Reliability. Again, chemical composition, heat numbers, coil numbers, production dates, specifications, all contained. You know, for decades, That's how this product was accepted, right? On certification. So again, this is just giving you guys all some insight on what is included within these mill test reports. Getting near the end here, gang. So, again, more information. Where can I get more information? This presentation, just like all the others, will be posted on the site. You'll be able to hear it all again. You'll be able to look at the slides if you like. Here's a shot of the NCSPA homepage. On the header, you can see there are Real Deal on Steel webinar series. You can go to that link. It will take you to the past recordings. Usually takes us a few days to get our latest recordings in a position to post. Typically, it'll probably go up on Monday, next Monday, this particular recording. But all the information is accessible from here. Corrugated steel pipe design manual. So now I'm going to show you a couple of screenshots of our quality program web pages. So this is the home page for the quality program. Here you can download the standard. You can download the fee schedule. You can download the program requirements. This map shows you all of the facilities that are participating in this program. This page is public. Anyone can view this page. This next page is private and custom, depending on your access level. As an administrator, obviously I can see everything. Quality management company and their auditors will be able to see everything, upload documents, etc. Participating member companies are only able to view and access information for their own facilities. Lane can't view Contex can't view metal culverts can't view Pacifics, so on and so forth. States, however, can view all manufacturers. Now, it might be a little bit difficult to see, but there are 5 milestones within the program, and those are the documents that you will be able to view and download. So the first one is the quality system manual and supporting documents within the quality system manual. That is all for the stage 1 review, right? Stage 1, stage 2. Stage 1 documents, stage 2 on-site audit. Once that's done, any corrective actions that are needed are also uploaded. Then that cues our auditors to say, all right, this facility is ready to schedule an on-site audit. So then an on-site audit can be set up. The results of that on-site audit can be documented. The report can be uploaded. And then any corrective actions that would arise from that audit would be incorporated and uploaded here. And then once everything is resolved, the certification can be issued. So those are the 5 primary steps that we will show within this particular site, if you will. So again, design manual is a great resource for folks to cover the board that we've discussed here, in our first 5, really. Well, I guess it would really amount to the first 4. The sustainability aspect is not covered in the design manual. The certification program is not covered in the design manual, but installation, design, coatings, all covered. 600 plus pages of really, really great bedtime reading if you're having trouble sleeping. But all kidding aside, full of great information, free download from the site. Of course, our installation manual, basic considerations for installation, also available. Free download from the site. Any projects that you're interested in. So these are all projects that we've collected, case studies that we've collected, projects of the year awards that we've handed out in the various categories, all found in the Find a Project page. I'm guessing there's well over 100 in there right now. We continue to build it. You can search and filter either by product coding or by project application, whether it's detention or retention, whether it's culverts, whether it's rehabilitation, whether it's structural plate. You can search by all of those various filters. The next slides are just, again, recaps of some projects that we have, some high-profile projects. This is our most recent Project of the Year winner for detention systems. What's this highlight? This highlights the flexibility of the installation of this trapezoidal design layout, large diameter recharge system. The next one, fabrication, flexibility and fabrication, as well as mammoth size, 144-inch diameter, bulkheads, customizable. You dream it, we can build it. Next project, just highlighting the long lengths, right? 60-foot lengths here in this particular project. 96-inch diameter, 60-foot lengths. What does that mean when you're installing a culvert? You don't have to have a joint necessarily. And then I think this is another picture. And then one last one. So again, flexibility and fabrication, right? So we can fabricate whether it's galvanized, whether it's aluminized, whether it's polymer. It can all be fabricated to meet your needs of your project. So that wraps it up here for us this afternoon, gang. We're going to do this all again in a couple weeks. Our next topic is going to be on rehabilitation. We have Jerry Salagi with Lane Enterprises and Scott Hensley with True North Steel as co-presenters for that particular webinar. So, please tune in a couple weeks. Thank you all again for attending here this afternoon. You can follow us on various social media channels. Thanks again. I guess we'll hop to any questions that anyone might have. See some folks typing. So we'll give you guys a few minutes. Again, thanks for joining us this afternoon. I hope you all are getting some good information out of what we're doing. Really appreciate the support and the attendance. Our attendance has exceeded expectations week after week. So thank you all, especially those that have attended these routinely. It's been great. It's been really great. No questions? Speak now, forever hold your peace. No, just kidding. Guys, if you think of anything after the fact, here's my contact information. Feel free, email me, call me. Happy to answer any questions. All right, gang. Thank you all for your attendance, participation. We'll talk to you again in a couple weeks. Stay safe, stay healthy. Be good. Take care.